Hello students, I hope you all are doing fine. Today I'm going to start the third unit of Ncert of Standard 11th. The name of this unit is Classification of Elements and Periodicity in Properties. Hello, I am Jayashree. So let's get started. We know that elements, they are pure substance which are made up of one type of atoms, isn't it? So in this unit, that is classification of elements and periodicity in properties, we are going to study about the following topics that you can see in the screen. First, we will discuss briefly about the classification of elements, and that is the historical development of the periodic table and as it stands today and the modern periodic law. Then we will discuss about the periodic classification and how it follows a logical sequence of the electronic configuration of atoms. Then the nomenclature and relation between the electronic configuration and periodic table. Then lastly, we will talk about some of the periodic properties, that is atomic radii, ionization enthalpy, ionic radii, electron gain enthalpy, electronegativity, and some of the periodic trends in the chemical properties of these elements. Okay, so in today's video, I'm going to talk about the classification of elements and what is the need of classification. So first of all, what is periodic table? Periodic table is the arrangement of elements with similar properties which are placed together. Okay. Now, before the beginning of the 18th century, only a few elements were known, and it was quite easy to study and remember their individual properties. However, the situation it became difficult with the discovery of large number of elements in the later years. So at this stage, scientists they felt the need of some simple method to facilitate the study of the properties of various elements and their compounds. After several attempts, the scientists were ultimately successful in arranging the elements in such a way so that the similar elements were grouped together and different elements were separated. So this arrangement of elements, right, that the similar elements fall within the same vertical group and the dissimilar elements are separated, it is known as the classification of elements. So this classification of elements led to the formation of periodic table, isn't it? So this question arises that why do we need to classify elements? See, classification is nothing but it is grouping things which are similar in some quality together in order to simplify our study or anything that we are doing, isn't it? Let's just take an example. If you want to buy some clothes, you will go to a mall or a shop, isn't it? And you will go to the just suppose you want to buy some t-shirt, then you will go to that section which contains t-shirt. All right, so in malls also we have different things which are grouped together with different things which have similar properties. They are grouped together and people they go there and buy it up. Okay, so this is how classification is done. So classification of elements was very much important. All right, as because without proper classification we cannot stay organized and we cannot stay focused. Okay, so now we know that the elements are the basic units of all types of matter. In 1800 only 31 elements were known. Okay, in 1800 only 31 elements were known. Okay, by 1865 the number of elements got doubled. All right, 1800, how many elements were known? Only 31 approximately. By 1865, this number got doubled, approximately doubled. Okay, and at present, we have 118 elements known so far. Okay, so since 2016, the periodic table has confirmed elements from element number 1, that is hydrogen, and to 118. The 118 is supposedly a noble gas named as organoson. Okay, and elements 113, 115, 117 and 118, they are the most recent discoveries and were officially confirmed by the International Union of Pure and Applied Chemistry. Okay, so students, you can see here that with such a large number of elements, it is very difficult to study individually the properties of all these elements. Okay, to remove this problem, elements were classified. Okay, so let's have a quick look at the historical development, or you can say just the timeline for the classification of elements. Okay, so this is the timeline of the classification of elements. Timelines means that it is the year-wise description of how the periodic table came into existence, the modern periodic table that we are following today, how it came into existence. So at first, in the year 1770 to 1789, okay, Lavoisier, he composed the first list of 33 elements, and he distinguished the metals from non-metals. It was his first achievement. Okay. After that, in the year 1829, Johann Dobryna, he gave the triads. Okay, you have studied about this in standard 10th also, Dobryna's triad. Okay, so in this year 1829, Johann Wolfgang Dobryna, he was a German scientist and he tried to arrange the elements with similar properties into groups. So what did he do? He identified some groups, okay, 3 elements each, and he called these triads. So Dobryna, he took elements such as lithium. He took elements such as lithium, sodium, potassium. Okay, and he calculated the atomic weights: lithium 7, 23, potassium, sodium, and potassium 39. So Dobryna, he showed that in each case of triad, the middle element had the atomic weight about halfway between the atomic weights of the other two. Okay. Also, the properties of the middle element were in between those of the other two elements of the triad. All right. So, if you will get the average of lithium and potassium, the atomic weights of lithium and potassium, you will get the atomic weight of sodium, that is 23. Okay. So that is why he formed 3 triads. One is the lithium, sodium, potassium. Other is calcium, strontium, and barium. Okay, and the third one is chlorine, bromine, and iodine on the basis of their increased atomic masses. Okay, so these triads are very much fascinating. But the problem was Dobryna, he could not make any more triads other than these 3. So Dobryna, he laid the foundation of classification of elements, but it was limited to only these 9 elements. Okay, but we have other elements also. So scientists, they found a way to classify the elements so that their study would become easier. After that, in the year 1862, D. Kenkotis, he was another scientist. He also made an attempt to classify the elements. He made a cylindrical table of elements to display the periodic recurrence of the properties. Okay. After that, in the year 1864 and 1864 to 65, an English chemist named as John Alexander Newland, he propounded the law of octaves. He propounded the law of octaves. So he said that every 8th element beginning from any element resembles the first elements in its physical and chemical properties. This was known as the law of octaves. So Newland, he was a very musical kind of a person. He liked music. So you can say here like this also. So we know that in India we say there are 7 Indian notes Saregama Padhani, and in Western there is also again 7 notes Do Re Mi Fa Sol La Ti. So when we sing it like Sare Gama Padhani, we again return to Sa, isn't it? So he said that every eighth element, beginning from any element, resembles the first element in its physical and chemical properties. All right. So this was the concept, or you can say the theory, which was given by John Newland. So, but remember one thing, that at that time all the elements were not known and the noble gases were also not known. Okay, so the problem here was uh, John Newland. He took some elements like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, and calcium. He took these elements, okay, and studied the recurrence of the properties. But after calcium the next element was not similar to aluminium. Okay, so the next element had properties very different, so this became the limitation. All right, so this law was applicable only up to calcium and it could not extend it further to other elements. So Newland also talked about the periodicity, that after a certain period, properties gets repeated. So the concept of periodicity was taken here from the Newland's theory. Okay, so this was all about the John Newland's theory. After that, in the year 1869, Dmitri Mendeleev, he gave the first periodic table. Okay, he was a Russian chemist. All right, and similarly, one another German chemist, Lothar Meyer, he was also working independently, and both the chemists in 1869 they proposed a new theory for classification of elements. All right. So we can say that while the here Lavoisier, after that Dobryner, they initiated the study of periodic relationship, but it was Mendeleev who was responsible for publishing the first periodic law. So according to Mendeleev, the properties of elements are the periodic function of their atomic weights. All right. So about this we will study later. Just have a quick review of this thing first. After that, in the year 1913, Henry Moseley, he discovered the modern periodic table. Okay, there were some limitations to Mendeleev's periodic table. That is why Henry Moseley he sorted out those limitations and he came up with this modern periodic table. So this was all about the timeline for the classification of elements. So now let's talk about the Mendeleev's periodic table. Okay. Now Mendeleev, hold on for a while. So this is Mendeleev's periodic table. So according to Mendeleev, it's his periodic law. It states that the physical and chemical properties of elements are the periodic function of their atomic weights. Okay. So Mendeleev he arranged the elements on the basis of their atomic weights. Okay. So Mendeleev arranged these elements in horizontal rows and vertical columns. Okay. See, the horizontal rows are known as the periods and the vertical columns are known as the groups. Okay. So he arranged these elements in such a way that the elements with similar properties occupied the same vertical column or group. Okay. Now he arranged elements in these columns and he arranged these elements in increasing atomic masses. So while he was preparing or arranging these elements according to their increasing atomic masses, and he put this vertical lines, okay, he kept this in mind that he would put these elements as the mass increased, as the property of elements were repeated. to, then he would put the elements below the element it was similar to. Okay, he found out that hydrogen, lithium, sodium, potassium, copper, these elements, they show resemblance in their properties. Okay, so he also realized that some elements did not fit in into this scheme of classification if the order of atomic weight was strictly followed. So he ignored this order again, and he, on the other hand, placed the elements according to their similar properties. We will come back to the anomalies later. Just let's have a brief discussion over this. At the same time, he was also very thoughtful that he left some gaps for the elements which are yet to be discovered. Okay, because he knew that some elements would be discovered in the near future. So he left some gaps for the elements. Okay, and for example, both gallium and germanium were unknown at that time. So Mendeleev, he published his periodic table with these gaps. Okay, so he named for gallium, he left the gap and he wrote it as, just a minute. For aluminium, he wrote it as, for gallium, he wrote it as Eka aluminium. Okay, Eka aluminium. And for germanium, he wrote it as Eka silicon. Okay, so Eka here is used to form the prototype. It is used to form prototype names for yet to be discovered elements. Okay, so this was all about the Mendeleev's periodic table, but there were some limitations. All right, there were some limitations, some anomalies. All right, anomalous means it differs from a norm or behavior, or which is different from the mentioned trend. So what were the limitations of this periodic table? You can see here that in this periodic table there are 8 vertical columns which are known as groups. Okay, and these are represented by Roman numerals 1 to 8, and for each group is divided into subgroups A, B, and except the 8th group. And in this table you can see there were 6 horizontal rows named as periods, which were further divided into 12 series. Okay, now there were some anomalies. So what are the anomalies? First is anomalous pair. Okay, now in the original periodic law based on atomic masses, it violated in case of 4 pair of elements in order to give them position on the basis of their properties. So actually these elements, they have higher atomic masses. Okay, and they have been assigned position before the elements having lower atomic masses at 4 places. I'm just again showing you this, that for example you can see here that argon, okay, argon is not there, cobalt and nickel is there. Cobalt and nickel, you can see here in here this. Then another anomaly is this one. Okay, and tellurium, you can see here the atomic mass of tellurium is 127.6, but that of iodine is 126.9. So clearly it shows that iodine, it has less atomic mass, but it has been placed just after tellurium, which has more atomic mass, but the reverse was expected. All right, so it is because iodine, it has same properties with that of bromine, chlorine, fluorine. Okay, that is why he placed iodine with those elements which has similar properties. Same is the case with cobalt and nickel. All right, so this was the anomaly here. So this discrepancy disappears if the elements are arranged in order of increasing atomic masses. So this was the concept. After that, the next discrepancy which was seen was the position of isotopes. All right, the position of isotopes. So isotopes, we know that they are the atoms of same element having different atomic masses but same atomic numbers. So the isotopes of the same element will be given different positions if atomic mass is taken as a basis. So this will again disturb the symmetry of the periodic table. Okay, in modern periodic table this problem was removed because one position was fixed for one atomic number. Okay, and since all the isotopes of an element they have the same atomic number, these are assigned only one position. So this problem was solved here. Okay, so these are the two basic anomalies which are seen. Some other anomalies were also there. So this uh, solves the problem of the classification. All right, the limitations which was there in the modern Mendeleev's periodic table was uh, resolved in the modern periodic table. Okay, so that was all about today's video, students. I hope you will be okay, and that's all for today, students. Thank you so much. Have a great day.